In this video, we will do image transformation and we will do ratioing of the images using the bands. So what are the learning objectives of this video? At the end of the lecture and the lab, you will be able to perform image ratioing, calculate the normalized vegetation index, calculate infrared percentage vegetation index, and calculate the difference vegetation index. So what you need is basically the band 4 and band 5 datasets which we have in lab 15, and we will take these bands and then what we will do is mosaic it and then mask it and then we will calculate the indices. Basically what is vegetation index is basically a number that is generated by some combination of the remote sensing bands. The literature indicates that the vegetation indices are generally based on empirical evidence, not on the basic biology, chemistry, and physics. So this has to be kept in mind while calculating the indices. The most basic assumption made is assuming that some algebraic combination of remote sensing spectral bands can tell you some useful information about the vegetation. They are fairly a good empirical representation or evidence. Some of the commonly used indices are ratio vegetation index, in which we take the ratio of near infrared bands to red band, and then there is normalized vegetation index, in which we take the difference of NIR and red band and divide it by the combination of the both bands. So this ranges from -1 to +1. And then we have infrared percentage vegetation index, and an infrared percentage vegetation index, what we do is divide NIR by the combination of NIR plus red band, and it ranges from 0 to +1. And there is last, what we will calculate in this class in this video is difference vegetation index, and difference vegetation index is the difference between NIR and the red band. So before calculating the NDVI, the digital numbers have to be converted to the reflectance. And what we will do is basically first of all use the formula, and using this formula we will convert the digital number to the reflectance value. And so let's see, we will understand all this maths behind doing all the combinations. So the multipliers and the band additive, these are the factors which you will find in image metadata file. And so we will use this multiplier by the band which we want the reflections on, and plus the additive. So you can get this MP and AP from the metadata file, and this will Q calculate will be the band which you will use, or the DN number of each pixel which you will use calculating the reflectance. So let's start doing the exercise. First step is to open the ArcMap. So let's go to the ArcMap. Now what we will do is add the data. So we can use the data set from lab 15. So we will add band 4 and band 5. So now here you can see I have added band 4 and band 5 for one scene, 152 and 41, and then I will include the band 4 and band 5 for scene second scene, which is 152, 42 and 152, 42. So now all the images are added. Now what I have to do is export it by assigning the no data value 0, so that we have 0 no data values. So what I will do is assign 0 to no data value and save the each scene as no data values. So I will include underscore no data. So I will save it. I will put it into the result folder in our lab 19 folder. So we have consistent data throughout this exercise. So we'll do same for other scenes. So for band 5, again export, assign nose 0 to no data values, and then save it. Give it a name and save it. So now do it for scene 2. 0 is no data values, give it a name, and then save it. So now we have saved all 4 scenes. What we will do is remove this data and add the data from the scenes which we have just exported as 0 as no data values. So I will remove all the scenes from here. Now then I will go to our result folder and then add all the scenes with no data values assigned 0. Now let's say add them. Now what we have to do is mosaic to a new raster dataset. So make sure that you have the same band. So if you are mosaicing band 4, so both scenes should be of band 4, and if you're mosaicing for band 5, your both bands should be uh, band 5. So as you have done in the lab 15, we will do same here. Mosaic to a new raster. Input B4 for both scenes. Assign it a location. Give it a name as B4. Put 1 into the band numbers and then press OK. So you will get new mosaic scene or mosaic raster. Now do same for band 5. Select both scenes, give it a location, give it name as B5, and number of bands should be 1. Press OK. Now you will get a new raster for mosaic raster for band 5. Now next step what we need to do is mask the Navaksha area, for which we need to calculate the NDVI. So we will add shapefile of Navaksha. So you can see we need only this much area to do NDVI on. So what we can use is masking tool. So I will use this mask tool, extract by mask tool. Go to toolset, spatial analysis, extraction, and extract by mask. Your input raster would be the band, so you can choose B4 and or B5, whichever you want, and then press. So here I'm choosing B5, using input raster mask as AOI. We'll save in the result folder as B5 underscore now option MB. Save it. You can save it as ISRI raster or TIFF file. So I'm saving as .tiff. So you can put .tiff extension there. So now I will do same for band 4. I will mask the band 4 area. Oh, band 4 to the area. Input is band 4. Your AOI is the feature mask data. Give it a name, and I will give B5 underscore NB or B4 underscore NB. Save it, press OK. So now you have both B4 and B5 bands, which you will use in calculating vegetation indices. You can remove all of the data set, and this is the only data we need now for further calculation. So now first step is to convert your digital numbers to reflectance. So from metadata file, I know the multiplier and additive factors. So you can use this equation 0.000 4 times 0 2 into B4 or B5, whichever band you have, then plus the additive factor. So I will put this equation here in raster calculator. I will save it as reflection 4 or reflection band 4. Save it, press OK. Now you will get reflectance for band 4. Now do same for band 5 and save it as reference underscore 5. So you will go into the raster calculator and do the same process. Here the only change is the input band, so it's B5 underscore NB, and and you will save it as reference 5. So here you have B5. And save it as ref_5. Now you have the reflectance for band 4 and band 5. Now you will do a sun elevation correction. So for doing sun elevation correction, you need sun elevation. So you can get this from the metadata file, and then divided the band, the reflections of the band which you have by the sinusoidal of the elevation. So let's do it in raster calculator. So you just have to put this formula there. Make sure that you have the correct image of reflectance of the band. So band 4 divided by the sinusoidal or sine of the elevation. So we will take this elevation value, put it there in raster calculator, and we will save this image as reflection band number, which is reflection_4 sun. So we will save this for band 4 and band 5, this correction. Press OK. So now you have a corrected image with the sun elevation. Now you will do same for band 5 and create a sun elevation corrected image for band 5. So let's do it. Open raster calculator. Put the formula again, just change the input band reflection, and you can save as reflection for 5 underscore sun. So now we have corrected all of the corrections. So we have converted our digital numbers to the reflectance and then corrected it with the sun elevation. So now let's see the formula for ratio vegetation index. So what we have to do is divide the corrected image of band 5 to band 4. So we have to take the ratio between band 4 and band 5. So we will use the sun elevation corrected images and save it as RVI. So our ratio vegetation index will be calculated. So now you have RVI image. Now let's calculate the NDVI. In NDVI you have to take difference of band 5 and band 4 and divide it by the sum of band 5 and band 4. So we'll use the reflectance sun corrected images, and you can use this formula, put it in your raster calculator and save it as NDVI. So now you have NDVI image. So you can use for NDVI analysis this image. So now we will calculate IPVI. For IPVI we need band 5 and divide it by the sum of band 5 and band 4, and we will save it as IPVI. So let's do it in raster calculator. So you need band 5, you then divide it by the sum of band 4 and band 5. Save it as IPVI. Press OK. So you will get now the IPVI image. Now you can calculate similarly DVI. In DVI you have to take difference between band 5 and band 4, and then you can save it as DVI. So here you just simply have to take difference of band 5 and band 4, save it as DVI. So now press OK. Now you have all the required vegetation indices, and now you are requested to see the next video in which we will do analysis using these indices, and what we will do is learn how to interpret them and how to infer knowledge from these images. So I hope it's straightforward to do this calculation, and you will see how it is useful in the next video.